that the quadrilateral is a parallelogram. Third condition, if AB parallel DC and AB equal to DC, that is one pair equivalent parallel. Not required AD and BC if AB parallel DC and AB equal to DC. If AB parallel DC, if AB parallel DC, if AB parallel DC and AB equal to DC, then this quadrilateral is a parallelogram. This is the third condition. Now fourth condition, if opposite angles are equal, if angle this angle equal to this angle and this angle equal to this angle, these are the opposite angle, A equal to C, angle C and angle B equal to angle D, then we say that quadrilateral is a parallelogram. Opposite, first condition, opposite sides are equal. Second condition, opposite sides are parallel. Third condition, if one pair are equal and parallel. Fourth condition, if opposite angles are equal. Fifth condition, if diagonal bisect. Bisect means equally divide AB, CD. This is diagonal, this is diagonal. This is O. If OA equal to OB and OC, OA equal to OC, if OA equal to this and this equal to this. In a quadrilateral, if diagonal bisect, then quadrilateral is a parallelogram. OA equal to OC and OB equal to OD. If diagonal bisect, then quadrilateral is a parallelogram. Another very important condition, which is sixth condition, is that if sum of the two adjacent angle, measure of the sum of the two adjacent angle, if this plus this equal to 180 degree, that is supplementary, or this plus this equal to this plus this equal to 180 degree, or this plus this equal to 180 degree, or this plus this. These are called adjacent angle. Sum of the two adjacent angle. This is A and B are adjacent, A and C are not adjacent. A or D are adjacent, D and B are not adjacent. Sum of the two adjacent angle is 180 degree or supplementary. Then quadrilateral is said to be a parallelogram. So there are six conditions. Out of these six conditions, if one condition is satisfied by quadrilateral, then we say that quadrilateral is a parallelogram. This is the condition. This is the geometrical definition of parallelogram. Very important definition of parallelogram is very important in class 9. So now how define rectangle? We know that in the earlier classes we study opposite sides are equal and angles are right angle. This is a rectangle, but it is not the actual definition of rectangle. In Euclid geometry, the rectangle is a parallelogram whose angles are right angle. This is a parallelogram and angles are right angle. Each angle is 90 degree. Remember that what is rectangle? Rectangle is a parallelogram whose angles are right angle is called rectangle. A parallelogram whose angles are right angle, then parallelogram is said to be rectangle. Next definition, what is square? Earlier classes we study four sides are equal and angles are right angle. This is not the actual definition of square. Definition of square as per Euclid, a rectangle whose all sides are equal. A rectangle whose all sides are equal is called square. Definition of rectangle, a parallelogram whose angles are right angle. square, a rectangle whose all sides are equal. This is called square. Another is rhombus. Earlier classes we already studied the four sides are equal, angles are not right angle. This is not definition of rhombus. Rhombus in Euclid's a parallelogram whose all sides are equal. If a parallelogram whose all sides are equal, then parallelogram is said to be rhombus. So first we define parallelogram from quadrilateral. First we define parallelogram from quadrilateral, and from parallelogram we define other quadrilateral, that is rectangle, square and rhombus. We define from parallelogram. So this is the definition of parallelogram, square and rhombus. Parallelogram, there are 6 conditions. Opposite sides are equal, opposite sides are parallel, one pair equal and parallel, diagonal bisect, opposite angles are equal, sum of the two adjacent angles is 180 degree. These are the 6 conditions. If one of the condition is fulfilled by a quadrilateral, then quadrilateral is said to be a parallelogram. From parallelogram, we define other quadrilateral, rectangle, a parallelogram whose angles are right angle, square, a rectangle whose all sides are equal, rhombus, a parallelogram whose all sides are equal. Now to define trapezium. Trapezium is not possible to define from parallelogram. So trapezium, definition of trapezium, only a quadrilateral whose one pair is parallel. This parallel this is distance between these two lines are equal. So these are parallel this. If this parallel this, then it is also a trapezium. So this is the definition of trapezium. Now another point is come, very important property. Remember that diagonal equal only in case of rectangle and square. Diagonal equal and equally bisect, not a square. Diagonal equal and equally bisect. What is equal and equally bisect? That is AB, CD. In case of a rectangle, AB equal to CD. In case of square, AB equal to CD. That is diagonals are equal in case of a square and rectangle. Also equally bisect, that is this side, this side, this side, this side are all equal. In case of square, this side, this side, this side, this are equal. But in case of a parallelogram, AB, CD, AC not equal to BD, diagonals are not equal. AC not equal to BD. In case of a rhombus, in case of a parallelogram, diagonals are not equal. In case of a rhombus, diagonals are not equal. That is AC not equal to BD, AB, CD not equal to. Also this side not equal to this side. That is OA equal to OC. Diagonal bisect but not equally bisect. That is this side not equal to this side. But in square, this side equal to this side. In case of a rectangle, this side equal to this side, this all sides are equal. But in case of a parallelogram, this side equal to this side, but this side not equal to this side. This side not equal to this side. All sides are not equal. Only bisect. That is this side equal to only bisect. Here equally bisect. Here only bisect. That is this side equal to this side and this side equal to this side. That is bisect mean OA equal to OC and OB equal to OD. In case of a rhombus also this side equal to this side, this OA equal to OC. But in case of square and rectangle, this all are equal. Remember this point. Another point is diagonal bisect perpendicularly. Diagonal bisect perpendicularly only in case of a square. This angle is 90 degree. In case of a rhombus also this angle is 90 degree. So diagonal bisect perpendicularly only in case of a square and rhombus. In case of a rectangle, diagonal are not bisect perpendicularly. That is, this angle is not 90 degree. This is not 90 degree. But in square and rhombus, diagonal bisect perpendicularly. This is 90 degree. In case of a rhombus, this is 90 degree. Remember that square and rhombus bisect perpendicularly, but rectangle and parallelogram are not bisect perpendicularly. These are the property of parallelogram and all other quadrilateral, defined quadrilateral in terms of Euclid geometry.